Okay, we are going through the basic concepts of traffic engineering. We have defined what is a traffic stream, why does it have changes, types of traffic flow facilities, types of traffic stream parameters. Then we discussed the two main types and there are three in each type. Okay, and then we have there were some factors we discussed, the K and the D and the peak hour factor. We looked at some equations. The last thing which we did was looked at the relationship between the two macroscopic traffic parameters. Okay, which were what? Which are the three macroscopic parameters?
Flow and density and speed.
Flow and density and speed. Okay, so we looked at the graphs, the equations from which the graphs are coming. We did some derivations. And I told you that the derivations can change from highway to highway, okay, because all highways will not have the same speed and the density, and it can change, so you need to keep in mind that what changes will happen. These equations apply to uninterrupted flow facilities. The equations which we did last time, they apply to uninterrupted flow facilities. And the reason is, what's the reason? Why don't we apply them to interrupted flow facilities? Sorry?
It doesn't take into consideration the stopping of vehicles.
It doesn't take into consideration the stopping of vehicles because of external flow which happens at the interruptions. Yeah, it can show you, we said jam density, right? So it has zero flow, but that zero flow is not because of any external interruption. That zero flow because of traffic itself. Okay, we looked at demand, volume and capacity, and we discussed that the demand in some cases can be more than the capacity. Okay, so when this happens, there are three main items which we should find out. Okay, again in this example try to focus on the concept, because traffic flow does not remain same. Okay, so I am showing you some lines here which are showing traffic flow, but these lines will not remain always like this. Okay, so try to focus on the concepts. Whenever demand goes above capacity, we have to know how long will be the queue. We need to know how much time the queue will need to be cleared. We call it the clearance time. And the third thing is, because of this situation, how much total delay and how much average delay will be caused. Okay, so the first two items, the first item is related to the road space, second item is related to the time, the third item is related to time of the driver, right? The delay is for who? The driver, right? Okay, so these are three main items which we need to know whenever what happens. When should I know this? Yes. The demand is higher than the capacity. Okay. Now you look at the graph. On the x-axis, time. On the y-axis, we have what happened with these chairs. Like, or you guys are breaking them, right? That was broken by him, right? Last time.
It's not broken.
Huh?
It's not broken.
They are broke? Okay. Why are you not sitting on that? Okay. On the x-axis time, on the y-axis flow, you see two lines there. One of them is showing capacity, the other one is showing demand. Okay. Now which one is showing capacity?
The right one.
Huh?
The straight one.
Why the straight one?
Because it's a maximum capacity.
Because the maximum capacity. Is it the maximum value? That's why you are calling it capacity?
No, it's constant.
It's constant. Okay. Capacity is constant. Demand can go up and down. It goes up and down with respect to time. Okay. And why does it go up and down with respect to time? Because there are other factors. Okay. So what is happening here? So they have kept it very simple. If this is between two numbers, that means the midpoint. So if it is between 0 and 60, that's a point for 30. Okay. The first 30 minutes Okay, what is high? Capacity or demand? Capacity is high. Any problem on the highway? No. Okay, it's like a partially filled bottle. No problem. Okay, the water which you have can easily fit into the bottle. No problem. Okay, then this is 30 and this is again between these 2 points, right? So again it's a midpoint, 30 to 90. 30 to 90. How many minutes? Huh? 60, right? Sure? Sure? Without calculator? Sure? Okay, good. So in these 60 minutes, the demand has gone up. Okay? So, and then after time 90, the demand goes down again and it is below capacity. Okay, so things start to get better when the demand go below capacity. Okay, now we need to know these 3 things, right? We need to know these 3 things. What is the starting point of all of them? And the timeline. When all of them start? 30, right? All of you agree? The delay will start at 30, the queue will start at 30. Okay? The delay will not start at 30?
Yeah.
Why not?
Because it wasn't on the edge of the capacity, and then there was more demand.
Okay,
It was
good
below
point.
capacity.
Yeah, good point. Yeah. Yeah, that is the real or the practical scenario, that it does not jump like this up and down. Okay, this is like a simplistic diagram to show you. Normally it is like inclined. Okay, so yes, but to make my life easier during the class and to make your life hell during the exam, this is the example it is in the class. The other one, since you mentioned it, will inshallah come in the exam, right? Inshallah. Okay. So if it comes, nobody cries, okay? Yeah? Okay, and it will be because of him. Sultan, right?
Yes.
Okay. Proud of that. Okay. But in this case, since there's a jump, sudden jump, okay, at 30, so all these things, 3 things will almost start at the 30 minutes time. Okay? But when will be the end of these things? When will the queue will go? When will the queue will clear? Huh? 90 minutes? At 90 minutes the queue is gone?
91.
91, very good. Now somebody say 91.1. Come on. Yes. At 90 minutes the queue will be gone?
No.
No? After that. Because the queue will have built up. It's not a queue of one vehicle. Okay? So there are number of vehicles in the queue. And these vehicles need time to clear. Okay? They are not flying, they are not vanishing, they are moving, right? And the movement will be one after another, right? So this movement will need time. Okay? So they are starting at 30, but the end is not 30. Okay. Now let us start with the first one, the easiest one. Okay? The maximum length of the queue. Okay? How many vehicles in the queue at any particular time? Tell me. How many vehicles will be in the queue at any particular time? At time 30 minutes, for example. How many vehicles in the queue? At time 30. Exactly. Q is the difference of what? Q is the difference of area. Q is the difference of? Q is the difference between what? Demand and capacity, right? Q is the difference between demand and capacity. Demand is higher, capacity is lower. The difference will be the vehicles which will remain in the queue, right? Simple? Okay. Your bottle has a capacity of 1 liter. Okay. And you are trying to pour into 1.5 liter. So how much will be remain outside? 0.5, right? The bottle can only take 1. Okay. Same concept here. The road can only take up to this much. The remaining is the queue. Clear? Okay. So at this point, this is 120. Your capacity is 70. The difference is Q, right? The difference is Q. Okay. How many? 120 minus 70? 75. 70, right? And you are teaching statistics on YouTube. Please close your channel. Somebody report him, please. 70 minus 120 minus 70. Huh? 50. See?
The capacity is 75.
You make the videos. Huh?
The capacity is 75, not
Who's that?
70.
Who's that?
See the line in between.
See the line between. Okay.
23.4.
Okay. So how much? 45. The answer is still wrong. Okay. Okay, clear? Clear? This happened when? At this time, right? This is time 30, right? Okay. Is it continuing? Is it continuing? For how long? It will continue for how long?
60 minutes.
60 minutes. So multiply by 60, right? Every minute this the same thing. Every minute the same thing will happen, right? Every minute the demand is 120, the capacity is 75. Okay. So what is the Q we have? 1000? 2000?
2700.
Okay. Any problem up till now? Clear? Okay. Now we need to know what the clearance time of the queue is. Okay. Now what will start to happen at time 90? What will start here? Something will start here. What will start? Huh? Yeah, because of this change, the demand dropped. What will start? The queue clearance. Okay, so the queue clearance starts from here. Up till here, queue was building. Up till here, the queue was building. Okay, so until the demand goes below capacity, the queue cannot clear because there is no space to clear, right? Where will these vehicles go from the queue? Okay, the road is completely packed up to the capacity. So these vehicles don't have the chance to go. Okay, they will start going after they have some extra space. Clear or not? Okay. Now how much queue you had? Okay. From this point onwards, these 2700 will start to clear, right? How many are cleared per minute?
10.
The difference, right? Again, take the difference. Okay, so this one is 75 and this one is 65. Okay, so their difference will be the vehicles which are clearing from the queue. Got it? Okay, you have extra space of 10 vehicles, which will be utilized by them. Okay, so every minute, how many vehicles? 10, right? Every minute 10 vehicles. So how many minutes for 2700 vehicles?
Remove 0.
You were saying something? Sure.
It's 4 hours and 30 minutes.
Okay, clear? Any problem up till now? It's all clear? Okay. So we have done the two parts here, which was the clearance time and the length of the queue, the maximum length of the queue. Okay, so if the graph changes, you need to keep in mind that the queue is difference between the demand and capacity. Okay, and the number of minutes this difference is positive, you will multiply. Okay, like we did here. Clear? And the clearance time will start when the demand goes below capacity, and then you will see how much extra space you are having. Divide by that. Okay, clear? Okay. Now for the last item, which is the delay. Okay. We have to do some extra calculations. Let me see. Okay, we'll do it here. You can draw this graph. This graph is between two rates of flow. The graph is between two rates of flow. On the x-axis you see time. On the y-axis you see the rates of flow. Okay, and they can be the rate of arrival or the rate of departure. Okay. Rate of arrival means what? the rate at which vehicles are coming, right? And this depends upon no demand, right? The rate at which vehicles are coming, this depends upon the demand, okay? And the departure depends upon what?
Density.
Capacity, right? And the demand is less than capacity, the departure will be same. If the demand is more than capacity, then capacity, right? This is what we saw. Okay. So how do we draw these curves? Now keep in mind, these numbers are cumulative. Okay, so I'm looking for total number of vehicles, starting from 0, total number of vehicles. Okay, so for example, if what do I need? Okay, so time, vehicles arriving, vehicles departing. Okay, I'll take the time 0, 30, 90, okay, after 90, what? Okay, so the times are 0, 30, 90, 360. Now can you look here and tell me why? Why I have taken the times at 0, 30, 90 and 360? Why not 0, 30, 60, 90, 120, 180, 150? Yes?
Because at those points you mentioned, it flips.
Yeah, something happens, right? At these points something happens, okay? So I don't want the intermediate points, okay? From 0 to 30, things are same. From 30 to 90, things are same. So when they change, we will take the next point. Got it? Okay. So 0 to 30, the demand was less. 30 to 90, the demand was more. 90 onwards, we have the queue clearance. Okay. And what is 360 then? What is 360? Yes.
You will clear at 360.
But we said 270?
You said 270.
270 from 90. Okay. We said queue clearance starts from here. So this 270 is from here. So to get the time, total time, it will be 270 plus 90 this. Okay? Okay? Clear or not? Everybody? If I'm not coming any day, you can like take a lecture, right? Okay, now we have to calculate number of vehicles arrived, number of vehicles departed. The first one is 0 and 0 because this depends upon the rate of flow, right? So 0 minutes means 0 and 0. Okay. Then 30 minutes. They are arriving at what rate? What is the rate of their arrival? Okay. And what is the rate of their departure? At what rate they are leaving? No. Here. 50, right?
Yeah.
It's less than capacity. There is no queue. So arrival and departure are equal, right? Okay. Let me take it over there. Okay. So, sorry. What was it? 50 into 30 and same here. How much? 1,500. What did I do? Okay, 1,500 and 1,500. So this shows that from 0 to 30 minutes, 1,500 vehicles arrived, 1,500 vehicles left. Is there a queue here? No. Okay, which is shown by there is no difference between the two numbers. When the difference comes, the queue is there. Got it? Okay? Okay. From 30 to 90, they are coming at the rate of 120, right?
Yes.
Okay. And they are leaving at the rate of 75. Okay, so this is where the difference will come. But I said this is a cumulative number. It's a cumulative number. So you have to add the previous value as well. So 1500 plus 120 into 60. Okay? Okay? Now how much is that? 7,000? Huh? 8,700. Okay, and what change will I make here? Tell me. Hassan. No, yes. You are also Hassan, right?
Yes.
Okay, you tell me.
With
The
water-
sleeping one, yes.
With the water we can prove plus the 180.
180. Now what should I do here? Now these are vehicle departing. So
75 by
you are Hassan. Change your name. Yes.
like he says 75 by
Okay. Tell me. Yes, tell me. Huh? No, you, Sultan. Yeah,
75 by
the Sultan of Sibyl. Yes.
75 by the time.
75 by 75 by bye.
4,400.
Okay. The rate at which they were leaving capacity for 60 minutes, right? Okay, and this number is from previous, just to make it cumulative. Yeah, how much is this?
6,000.
6,000. Okay, if I want to check if this number is correct, if these two numbers are correct, if I want to check it, can I check it? I can, but you guys should know. Yes?
8,700 minus 6,000.
And this should be equal to what? The Q. This is the Q, right? Okay, so when you take the difference, this should be equal to the Q length we have calculated here. Okay, which is this one. Okay, if it's not equal, that means there's a mistake somewhere. Okay, now here, again I will take the previous number because it should be cumulative, plus how much? Now vehicles arriving. They are arriving at the rate of this thing, okay, which is 65. Okay, remember the demand dropped, right? The demand is this one now, 65. So arriving is according to 65 per minute. Okay, and they are doing it for how many minutes? 270 minutes, right? The interval, okay? Yes.
26250.
Hmm?
26250.
26250. Can somebody tell me how much will this number be? Hmm? Same number, right? It should be the same number. Why? Why should be the same number? Because the Q is gone, so they should become equal again. So there was no Q here, numbers equal. No Q here, numbers equal. Q here, numbers equal to the length of the Q. Okay? Q gone, numbers will become equal. Okay? And how do I get this? 6,000 plus, they are going at this rate, right? 75. So 75 into 270. Clear or not? Any questions? Umayma? Clear? I'm doing this since last semester. Anybody enters the class, I ask him, clear? They say yes. I've not met any single girl or boy who says, no, I just arrived. Yes, it's all clear, which is very good. Okay, so I come here and I plot these numbers. Okay, this is my x-axis and these numbers on the y-axis. So that's why you see these two lines. Okay, this line is represented by here, and this line is represented here. Okay, clear? Clear? Okay. Now we are doing this to calculate the delay. Okay, we are doing this to calculate the delay. Okay, so so this is done. We plotted the lines. Okay, now the delay is the area between these two lines. The delay is the area between the two lines. Okay, now since you already, wherever there was a change, you put a point there, right? Okay, if there was a change there, at 90 there was a change, at 30 there was a change. So I put a point there in my graph, right? Okay, so now from one point to the other point, I can calculate the area between the two lines using this method. Okay, between 2 points, remember, between 2 points, okay, I can calculate the area using this method. Okay, if you miss the change, then this method will not work. So if I miss the 90 point, I did not plot it, okay, then obviously this method will not work because you missed the change, the point where the slope was changing, you missed it. Got it? Clear? Okay? Okay. So what is this method? Half base into height. Half base into height. And this is what? Area of circle, right?
I think it's rectangle.
Huh?
Rectangle, I think.
Triangle? Sure. Okay. It's still, right? It's still triangle, right? Yeah. I've never known. Things change. 20 years ago when I was studying, it was triangle, maybe now it's circle. Things change, right? Or rectangle. Okay, so from now, keep one thing in mind. You will calculate the area where there is an area. Where there is a difference between the two lines. Is there a difference between the two lines here? No. Is there a difference between the two lines here? No. So there is no area. Okay. So the area calculation will start between these 2 points and these 2 points. Okay. So what did I say? Half base into height here, half base into height here. Okay. What is your base? Time is your base, right? Okay. So between these 2 points, what is your base? 90 minus 30. So half base. Okay. What is the height? The difference, right? The difference on the y-axis. How much difference do you have on the y-axis? Okay. 8,700 minus 6,000. Got it? Clear? So this is why we did the table. Even if you don't plot the graph from the table, if you have met all the points, you can calculate your area. Okay? Clear? So half base into height between these 2 points and half base into height for these 2 points. Half base height. Half base height. Okay? Clear or not? Okay. Why it is 2,700? Why this one is 2,700? There is no difference here. Why don't I take it 0? Yes. We need the difference, right? We need the difference. If it was 0 and 0, then why am I doing this? Okay, so you have to take the difference where there is a difference. Okay, got it or not? No.
How can I get
The difference, you need the difference between the two lines, right?
Yes.
Okay, so you will take the difference where there is a difference.
Yeah,
So I have, if I take the difference from here, it's 0.
Yeah.
So I have to take the difference from the starting point. You can take the difference at the starting point, the end point, right? Got it or not? Okay. So for the first case, you see here, for this case, I took the difference of what? These two values, right? Which is the end values. For this case, if I take the difference of end values, it will become 0. The whole thing will be gone. I'll go back to the starting point. Okay, so you have to see, because it will happen.
But there is difference.
Okay, because Q is starting and Q is ending. So there you have to see, yes. If there's a difference between at the start and the end, both, right? We take the end. Yes.
Why do we need the
Sorry? For delay. For delay. To calculate the delay. To calculate the delay, we need the area. Okay. So now what you are multiplying? This is time. This is volume, right? This is time and this is number of vehicles, not volume. This is time and this is number of vehicles. Okay. So the final units will be vehicle minutes. Okay. Vehicle minutes. Okay. So what does this show? That 445,500 vehicle minutes were lost in from time 0 to time 360. Okay. So if there were 445,500 vehicles, then every vehicle lost how many minutes? 1 minute. Okay. If there were these many vehicles in the traffic flow, in this situation, every vehicle has lost 1 minute. Okay. This is a way of saying it. Okay. But forget about the vehicles. How many minutes you lost? Okay, because of this situation, how many minutes are lost? These many. Got it? Okay, this is a total delay. This is total delay. Okay, so I am delayed by 10 minutes, you are delayed by 5 minutes, you are delayed by how many minutes? Right? Okay, so if you combine all our values, this is the total. Got it? Clear? Okay. Sometimes we need the total, sometimes we need the average. Okay. So if you need the total, this is in minutes. If you need the total in hours, this is in hours. Clear? Okay. Now if you need the average, okay, you have the total. How do you convert total to average? Divide by what? Number of vehicles, right? So I need the number of vehicles. Okay. How many vehicles in the queue? How many vehicles? I will divide by the number of vehicles in the queue, right? Those vehicles who face the delay, right? So how many vehicles face the delay? 2,700. 2,700. Not by the time. Time divided by something. Time divided by number of vehicles. Number of vehicles will not be 2,700 because this is the maximum length of the queue. This is the maximum length of the queue. At one particular time, at time 90, this is the number of vehicles which were in the queue. Was there no queue before? Yes. There was a queue before, right? The queue started when? Okay. So what happened to the vehicles which came before this, after 30? They were also in the queue, right? They were also in the queue. Maybe not at this time, but they were in the queue at some time, right? Okay. And did the queue finish or did the queue clear at 90? Did the queue clear at 90? No. Okay. So what happened to the vehicles which came after it? They were also in the queue, right? At some time. The queue was shorter, but they were also in the queue. Okay. Clear or not? Everybody? Okay. So I need to know the number of vehicles which started from here till here. Start of the queue till the end of the queue. The total vehicles from here to here. Okay. How many? Now you have the chart, right? How many? Huh?
26,000.
No, 26,000 from 0. Do I need it from there? No. I need it from 30 to 360, right? Okay. So this minus this. Clear? Okay. Number of vehicles in the queue, which should be this. Okay. Yeah. 24,700. Got it? Okay. The time from where the time at which the queue started till the time at which the queue cleared. All vehicles during this time face a delay. I came, there was a vehicle in front of me, stopped, I stopped, right? This is my delay. The next car came, now we are 2 in the queue. That car also will face delay, right? And we could keep on going and going and going. But at some time the demand drops. So now we are moving. But are we out of the queue? No. So we are still facing delay, right? Got it or not? Any questions? Okay. So this number is this much, the total delay is this or this, and how many vehicles faced it? 24,750. So the average will be this number divided by 24,750. Okay, so the average delay is how many? 18 minutes per week. Okay, clear? So it's an average number. Somebody may have faced more delay, somebody will have faced less, but on average it's this much. Okay, so we had this situation over here. Demand went over capacity for 60 minutes. Okay, so I need how many vehicles maximum will be in the queue. Queue is not constant. Queue increases and decreases, but how many vehicles maximum? Okay, so the queue starts from here and it will keep on growing till this point, right? Okay, so I calculated how much will be the difference between these two lines from here to here. Okay, that was 2,700. Okay, then I calculated how much time I need to clear the queue, which was the time at which the demand drops below the capacity and how much difference is there. Okay, and then I divided by the total number, I got the time at which the queue will be cleared. Then we shifted to the delay calculations. For delay I must know total vehicles arrived, total vehicles left, and I need it for every important point, every point where some change happened. Okay, so we calculate number of arrives, number departed, we draw these lines, and then between these two lines we are trying to find out the area. Okay, and the area is half base into height. Yeah, so your question was if you have difference at both ends, right? In that case, you can take the average. Yeah, you can take the average. It becomes like a parallelogram, not a triangle. Okay, so we got the total delay by taking the area. Okay, then you see where the queue started, where the queue finished. All these vehicles are part of the delay. They are part of the queue at one point or the other. So total divided by this number will give you average delay. Okay, any questions? Clear?
The area is this area.
Yeah. Okay, what we have seen in the previous example is called a breakdown. Okay, meaning demand goes over capacity. A breakdown means demand goes over capacity. Okay, a breakdown, there are some sensitive areas on which breakdown normally happens. Okay, and these are the areas where flows, different traffic flows can come together. Okay, because if you are on this highway and nobody can enter, then there will never be a traffic jam. If I can close the entry and exit to the highway, there will never be a traffic jam. You have the same number of vehicles from start to end, right? And these number of vehicles cannot be more than the capacity. Okay, so the breakdown only happens when you have merging of the flows. Okay, where it can happen at intersections, very common, right? Okay, you have a highway, somebody is coming from right, somebody is coming from the other side, somebody is coming from the left hand side, somebody is taking U-turn. Okay, so the total can be more than the capacity. Merge points, I will show you in the next slide, but there are some cases in which two highways are coming and they merge into one highway. So two becoming one. Okay, so again, flow from here, flow from here. Total could be more than the capacity. And the last one is ramps. So you are going on the highway and there's a ramp coming up. So the highway is totally jam-packed now, and then you have more people coming from the highway. It can be more than the capacity, okay, which you often see on the main highways in the morning. This is the merge point. You see two highways merging onto this one. Okay, so for each of the contributory highways, you can see the demand, capacity, and volume. Okay, so capacity, both of them 4,000. Demand here 3,800, demand here 3,600. No problem, right? No problem for this highway, no problem for this highway. Okay, but combined, when they go over here, the capacity of this highway is 6,000, more than these two, right? 33% more, which is a lot. Okay, maybe you have provided 2 extra lanes, but how much demand we have for this highway? How much? Huh? How much we have? How do I get this number?
Demand for approach.
Yeah.
Add those two.
Okay, it's very simple. If you have 2 highways or a ramp coming or people coming from different directions, you just add them together, you get the demand of the next one. Okay, this is very easy and common. Okay, so now this becomes more than the demand, right? Okay, so how many will pass through this highway? 6,000, which is the capacity. Okay, the remaining will be in the what? In the queue, right? Okay, and the queue will be here. Clear? So they call it the queuing area. We call it the queuing area. Okay. Now here you see when the demand, and even in the previous example which we did, if demand is less than capacity, volume is equal to demand. If demand is more than capacity, volume is equal to capacity. Understood? Clear? Any problem with this? Okay, now we will start the problems. Okay, now we start messing up everything. Okay, so we have a highway. The highway is, now this is the second case now, the ramps. Okay, so you see the inclined lines are ramps. Okay, these two are entering ramps. These two are exit ramps. The initial flow, initial demand of the highway is given, 2,200. Demand of each ramp is given. This much is supposed to come in and this much is supposed to go out. Clear? Okay. The capacity of each of the segments for the main highway is given. Capacity of ramps is not given, it's not our concern. Okay? So, if you go to section 1, the demand is 2,200, capacity is 3,200. This will be how much? The volume, yes, the volume. 2,001. Okay, next one. 2,200 already there. Demand of the ramp 800. Total? Okay. Clear? Any problem till now? Okay. Next one. 3,400. Where did I get 3,400? Capacity. Why capacity? Why did I do the same thing here? 3,000 here, 700 here. So 3,700, right? So why do I have 3,400? Because the capacity is lower. Okay, the demand is higher. Okay, so we can only have 3,400. Clear? Any problem? Okay. Now, next one. 2941. It was 3,400. The demand on the ramp was 500. 3,400 minus 500 is not this. Okay, just trust me on this. People who are thinking, it's not this. Okay, so from where did I get 2941? Okay, this is what we call as the network effect. What we call as a network effect. If you suppress the demand of one section, this will affect the demand of the proceeding sections as well. Okay, the actual demand here was not 3,400. It was more, right? And you suppressed it because of the capacity. Okay, so demand, the actual volume of this ramp will also not be equal to its demand. It will also be suppressed. Okay, imagine it like this. There were 3,700 people who are trying to enter from here. Out of this 3,700, 500 will try to pass from here. Out of the 3,700, the initial one. Okay, clear? So if this was 3,400, then all 500 people who are trying to get out from here will have been here and they would have got the chance to move. Okay, but out of the actual 3,700, I'm only allowing 3,400 here. So out of the actual 500 which are trying to get out, some of them are stuck here. You got my point? Okay, this 500 was coming from here, right? And the people who are supposed to come here, some of them are in the queue here. So they did not even reach this point. So how can 500 leave from here? Out of these 500, some of them are in the queue here. Okay? How many are in the queue? Then you take the proportion. Okay? We will use equal proportion. So the actual was 3,700. Okay? The actual was 3,700 and we allowed 3,400. Okay, which is how much now? 459. 459. 0 point something, yes. 0.9.
Multiplied by the.
Yeah, now I will multiply it with the 918, keep it 918, no problem. Now I will multiply with the, so this much demand is suppressed. 91 or this much demand is allowed out of the actual, this much demand is allowed. Okay, so the next segment which has 500, okay, out of 500 the actual allowed will be 91.8% of 500. Okay, okay, so this is how you got 459 approx, obviously. Okay, clear? Any questions? Same will be applied to the next one. Same will be applied to the next segment. Okay, so how did I get 368 here? What multiply by what? 400 multiplied by? Yeah, 191. Got it? Okay. Okay. So you know how much is supposed to get out from here? So 3,400 minus this number. This one. 2941 minus this number. This one. Got it? Clear? Any questions? Okay. Now some terminologies and some scenarios which are happening, some cases. First of all, the segment in which the demand goes over capacity, the breakdown happens. The segment in which the breakdown happens, we call it the bottleneck. Okay, the segment in which the demand goes over capacity, which is causing the queue, the segment which is causing the queue, the segment which is suppressing the demand, we call it the bottleneck. Okay, why we call it the bottleneck?
Because it's smaller than the
Yeah, the bottleneck is usually smaller than the, or any neck, right? The neck is smaller than the rest of the body. So that's right. Okay. Clear or not? Okay, so we call this as the bottleneck. So we have learned about breakdown, we have learned about bottleneck, and we have learned about the network effect. Okay, if something is suppressed in the previous segment, it will create an effect on the remaining segments as well. Okay, what else? Yeah. Now you see here, in this segment, volume equals to demand. Volume equals to, it was demand, right? This plus this, demand. Here volume equals to capacity. Here volume equals to anything? Is it equal to capacity? Is it equal to demand? The actual demand was something more, right? Okay. So now the volume is less than demand, less than capacity. The actual volume is not equal to demand, not equal to capacity. So you are not utilizing the highway completely. This is called as demand starvation. Okay. The starvation is when you need something but you cannot have it. Okay. So the highway can have a higher flow, a higher volume. Okay, this highway can have volume up to how much? 3,000, right? It's not even reaching this point. Okay, so it's not fulfilling his hunger. Okay, so that's why we call it demand starvation. Okay, and what was the reason of demand starvation? Huh? Ramps? Bottleneck breakdown. Okay, ramps are there, right? There were ramps before this as well. Okay, they did not create the breakdown. So the demand starvation normally happens because of a bottleneck or a breakdown which happened earlier. So this is the network effect. This is the network effect, remember. Okay, so demand starvation is when the volume dips below demand and capacity both. Okay, and it is because of a bottleneck or breakdown which happened earlier. Okay, now you come here. Who will tell me the actual demand of segment 4? Tell me. The actual demand of segment 4. How much is the actual demand of segment 4? 3,200, right? Okay. What is the capacity of segment 4? 3,000. Okay. Does it look like a bottleneck? If you look at these numbers, is it a bottleneck? It should be. Okay. But what happened? It didn't become the bottleneck, right? Because of? Yeah. And what did we call this phenomena which is happening in segment 4? Demand starvation. Okay. So a segment where demand starvation happens and the actual demand is more than the volume. Oh, sorry. The actual demand is more than the capacity. We call it the hidden bottleneck. We call it what? Hidden bottleneck. Okay. So the actual demand was more than the capacity. First. Second, this one has demand starvation. So it did not reach the capacity. Okay. So this is called as hidden bottleneck. A segment where both these things happen. A segment where both these things happen. It has demand starvation. It has demand more than capacity. Okay. That segment is called as the hidden bottleneck. Clear or not? Okay. It has happened on many highways in Bahrain actually since COVID. Because during COVID, you remember, they have built a lot of bridges. They are still doing it. Okay. So when you build a bridge before, what will happen? You are increasing the flow, right? Increasing the flow. So let's say this is my bridge. Somebody told me I have a problem here. Okay, we are having a flow or depression of, it was supposed to be 3,700, now it is 3,400. Okay, so there's a problem here. We need to solve the problem. Somebody comes and says, okay, let's build a bridge or let's increase the lane. Okay, so you increase the lane and you let the flow go from this segment. Okay, so now there is no problem here, but the problem will appear on the next segment. Okay. If you are coming from Zaid town or Ali, then you have the turn which is coming towards the main highway. The IKEA, yeah. Okay. They increase the lanes there. Okay. So earlier when there was one lane after the IKEA, like after this entry, the traffic was usually less. Like there was less queues and so on. After they make it into 2 lanes, now the flow coming here from here is more. So the queue continues even after that as well. Earlier there was a problem before this only. Now the problem, you may see less flow before this, but the problem has shifted from here to the other point. And there could be other points where this has happened, because this happens. Okay, you are allowing more flow to go forward, then the other section must have the capacity for the new flow. Got my point? Okay. Okay. We've discussed all of these. These are the examples which you can see in the books, the 4th edition, the 5th edition. I believe I uploaded both of them. The examples are same, the equations are same, so this should be easier for you to have a look. Okay. The next thing we will start today is the traffic data collection and reduction. This is from chapter 9 of the textbook. And as I mentioned, when I say textbook, I mean the 5th edition normally. Okay, so if it is something else, I will mention it. The course outcome which we are trying to cover is the ability to have skills for traffic data collection and analysis. Okay, the word here used here is reduction. Okay, reduction does not mean you reduce the data. Reduction means you are reducing the number of values which will represent your data. Okay, so you tell me what are the grades normally in this class, like you must have done before taking this course, right? What is the grade norm? Okay, so earlier last semester there were 20 students. I can give you 20 values, right? I can give you one average value. Okay, did I reduce the number of values? Yes. Does it give you the idea about the entire data set? Yes. Okay, so reduction does not mean just dropping the values. Reduction means you will take the entire data set, okay, and find out some representative values. So instead of 100, I only need 2 numbers. Okay, but these 2 numbers are representing the whole data set. Got it? Clear? And this is where we need statistics. And the people who are teaching them are not so good. They are doing it on YouTube as well. Okay. The traffic data. Why do we collect traffic data? It will tell you about the current state of the system. Okay, how much volumes you are having, where do we have cracks, where we have maintenance problems, where we have traffic jams, where we have signals and so on. Okay, then it also tells you about the current demand of the system. And as we have seen in the previous chapter, what you see on the road may not be the demand always. Got my point? Okay. And we need traffic data to do future projections as well. Something again we looked in the previous lecture, in the previous topic. Okay, if you need design hourly volume for after 20 years, okay, or you need volume to design the highway, you need some factors, right? The K factor, the D factor, the peak hour factor. From where will I come? From where will I get these factors? I explained at that time as well. You can rely on the standards to give you a range. But we did one example where we took the values from the range and there was a big difference between them. Okay, so these ranges in the books are not so accurate. Okay, so you have to rely on the actual traffic data for future projections as well. Okay, you need the current data. Before you start collecting the data, you must know what is the use of the data. Okay, so you have collected the data for your term projects, right? Huh? Some of you are thinking, oh, I was sleeping. My friend said, yeah, you have the data. You submitted, right? Now, you're looking at who is this guy. Okay, but you collected the data, right? What did I tell you? What did I tell you about the data? What do you have to collect? What did I say? Speed and number of vehicles. Okay. Which direction? Which lane? What type of vehicles? What are you doing? What type of traffic study is this? What was that? What was that? Just for fun, yes. And don't trust him. He doesn't have any idea of fun. So, what was that? I gave you a name, right? What was it? It was a trial run. Okay, it was a trial. Okay, so you may use the data, you may not use the data. But if you go with actual data collection, then you must know what data you need. Okay, like I said, you may use this data, you may not use this data, but you will only decide when you know what to do. Okay, so when I tell you for the next step, this is why you collected the data, this is what you have to do. Some of you would say, no, the data I collected, I cannot use it. Now you say that, yeah, I can use this data. But you can only say if I tell you what you have to do with the data, right? Okay, so this is what they are saying here. You must know the purpose of collecting the data. Now in your case, obviously I don't care wasting your time and you don't care about your life, so no problem. You will go there and collect it again, right? Okay, but when you will become engineers, say inshallah. You know what your inshallah means, right? So When you will become engineers, you will not do it like this. Let me go there and spend half an hour, 1 hour of my time, and we will see if the data is useful or not. No. Okay, you will spend money, you will have time, you will have other teammates with you, so you will not do it like this. Okay, so we don't need to waste our effort in the field. Right now, waste as much time as you want, which you are already doing. Then one thing you need to keep in mind, traffic data earlier used to mean, what is the meaning of traffic? What is the meaning of traffic? When I say there's too much traffic, there are too many what? Vehicles. Okay, this is the old perception of traffic data as well. Okay, which is again a common perception. Traffic means vehicles, traffic means cars. Okay, but now the new perception, the new purview of traffic data is that it should include all road users. It should include all road users. Okay, and there could be drivers, there could be pedestrians, there could be passengers, there could be bicyclists, okay, and bike riders and so on. Clear? Okay. So if you are including all of them in your traffic data, or you're thinking about all of them in your traffic data, are they all moving in the same point of the road? No, right? So you may have to study different facilities which are for specific road users. Okay, you may have to care about bus stops as well. You may have to care about pedestrian bridges as well, and the crossings as well, and pedestrian signals as well, and the bike lanes as well. Okay, so this is like the traffic data now has become more encompassing and including everything. Okay, traffic data can be collected in different ways. There are some databases which are available online. You can click on these links, it will take you to some traffic databases which are available online. Okay, this one is local, King Fahd Causeway Authority. This one is from US. Okay, and there are other databases as well. These are just two examples. So they are obviously traffic data is collected by who? Students of traffic engineering, right? But actually, who collects the traffic data? Huh? No. Which body? Which organization? The ministry, right? Okay. So ministries all over the world, they collect this traffic data and they upload it. Okay. So there are some open access databases and they're very, very large. So you will get like years of data for every day and so on and so forth. Then we have traffic data which is readily available and needs to be extracted. Okay, for example, you use maps, right? For navigation, you use maps. Okay, a new place opened somewhere and I have to go, I don't know where is it, I use the map. Okay, your route is recorded, obviously. Okay, while you are going over the map, your route is recorded. If the map is open, the navigation is recorded. Okay, and I told you in the last lecture that we have the vehicles which are driverless vehicles, right? Automated vehicles. Okay, these vehicles do not have drivers, so they have what? Sensors. They have sense. Drivers don't have, right? So they have sensors. Okay, these sensors are collecting traffic data, right? This is how the vehicle will move. Okay, so there are sensors and GPS trackers which we are using. They are already there. They are recording this data. Okay, so if you have access, you can extract this data and you can have your information. Okay, the speed of the car, the travel time, the number of changes, the acceleration, the deceleration, the traffic volume, you can have these things. Okay, so this is readily available traffic data, and I already gave the example of Causeway, right? Now they have, like, they don't have to count the vehicles, do they? On the causeway, do they have to count the vehicles? No. You already have a toll plaza where you are giving the tax, right? So if you just look at how much tax we collected today, they know the number of vehicles, right? What's my point? When you are crossing the causeway, you pay like a tax, right? Okay, 2 video or 1 video, I don't know how much. So, habits. Need to get this off. Okay. So what was I saying? Yeah. So these are available data sources. The point was some of them have the traffic data direct, some of them have traffic data, but it's not for traffic data collection. But because these systems are working, they collect traffic data automatically. Okay. So you can go to the causeway and they can look at their records. They even know at what time this vehicle entered, right? And what time this vehicle entered the other side. Okay. This time is recorded, so you can have all this information as well. Apart from these sources, if you have to go to the highway and collect traffic data, then you can do it in different ways. One is using manual techniques, okay, or there are some portable devices as well. You can put them on the site and they can record traffic data. Okay, so these are mainly where you need the people to stay on the site. Then we have some detectors and sensors which can collect traffic data for you automatically. So install them and leave. Okay, and this is what the ministries and the governments do at most of or at many points. This is how we generate these types of data sources. The data is collected continuously, okay, from these devices. So there are some permanent devices. There are some devices in which you have to be on the site to collect the traffic data, okay. And this one basically should go there. Okay, our phones are also collecting traffic data as well. You can have video devices as well. Obviously, video cameras are installed and they can collect traffic data for you. Okay, this is about the manual data collection. So when you go to the site and you start collecting the data manually, they have these counters. These are called as hand counters, and this is like a counting app. Okay, but like not any counting app. It has like you can define your geometry here. How many lanes here, how many lanes here, how many lanes here. Okay, so and here you cannot define the lanes, but you can fix the counters. So each button is a counter. Okay, so if I have 4 lanes, I can use one counter each for each lane, and I can use different sides for different sides of the intersection for different direction. Got it? Okay, so these are like specialized traffic counters. And then we have some portable equipments. Okay, you see these thin lines, they are very commonly used in Bahrain. They are called pneumatic road tubes. Okay, you will see the full name later on. Okay, so for these you put the tube on the road, the car crosses over the tube, it is counted. There is a counter on the other side, okay, at the side of the road, and it is automatically counted, but to put the tube and then to collect the data, you have to be there on the site. So when they start any road construction projects, they do this. Okay. Okay, where do we use traffic data? You have to manage the road system, right? You have to do maintenance, repair work for the road system. Okay, the signals, the bridges, the drainage channels and so on. This maintenance work depends upon the use of the highway. You will see some local streets which are where maintenance does not happen for 5, 6, 7 years. You will see some big highways, major highways, you will not even see a small crack. Okay, because that one is more important, this one is less important. It is used by more traffic, higher speed, more chances of accidents. So maintenance depends upon traffic. So you need the traffic data. If somebody asks you to get the traffic after 5 years, 6 years, 7 years, okay, you will need the rate of growth, right? Per year, how much traffic is increasing. Okay, so how do I get this growth rate? When I will look at the previous data. Okay, so you are looking for traffic after 5 years. Okay, so give me traffic for the last 5 years. I will know the rate. Okay, from year -5 to 0, it is increased by 5%. I can say in the next 5 years, it will also increase by 5%. So for this, to know the behavior of the traveler, of the driver, okay, at what speed they like to go, what is their maximum acceleration rate, how much spacing they want to keep, okay, these are driver choices, okay. These are driver choices. Okay, we have people who share the car. Okay, I'm going there. Okay, you are also going there. I will go with you. And we have people who will not do this, right? So these are choices. So how do you know about choices? When you observe them. Okay, the speed and everything, they're choices. Then we have looked at some equation in the last topic, right? We did some derivation in the last lecture, right? Okay, what was the starting point of the derivation? Where we know the speed and density of the road. Okay, the speed and density. So this is also traffic data. You have made any changes on the highway, you want to know if these changes are effective or not. Okay, for that we do follow-up studies. Okay, so to make the changes, I must know traffic condition. After I do the changes, I must know traffic condition after the changes to see what was the impact. Yeah, somebody comes and they do this. Somebody comes, goes to the ministry, I need permission to build a new mall in this area. They will not give the permission until you do a traffic impact study. Okay, and traffic impact study can be according to the size of your facility. If you say I'm building a villa, no problem. I'm building a 20-story residential building, you have to do the traffic impact study. Okay, so traffic impact studies are done to see the impacts of new developments, new construction. What will be the impact of this on the roads? And they, on the basis of the traffic impact, they calculate the impact on pollution as well, noise level, air pollution level, and so on and so forth. And the last one is to know the performance of the current road system. The performance of the current road system. Okay, and you know it's not constant. It changes with respect to time, right? At a particular time, one road may be performing very well. You are going at 120 speed. After 5 hours, the same road may be jam-packed. Okay, so the changes in performance of the system. Okay, so traffic data helps you doing all these things. Clear? Any questions? Okay. Next Monday we will have the quiz, the start of the lecture. Okay, lecture 1 only, the previous one.
Full lecture.
Huh?
Full lecture.
Quiz means MCQs true and false. Okay, there will be no calculations. Happy? Happy?
I like
Not happy.
calculations.
Huh?
I like calculations.
Okay. Okay.